Hello dear friends, welcome to Gate Academy Global. Before starting today's session, I would like to have the input or the concurrence regarding the quality of video as well as audio. Now, probably we had the problem related to the sound, probably now it has been sorted out. Just wanted to have the input from each one of you. Now, whether my audio is audible or not. It's perfect, no? Now it's audible, that's more than fine. Anyways, if the guy who have been attending my classes in the regular basis, they would have a clear-cut idea. Since probably 6 to 7 number of days, we were dealing the different kinds of the numericals based on the concept of probability, and specifically we were focusing over the word problem. Anyways, the agenda behind today's video is not very different. We are going to take around 4 to 5 well-designed problem based on the concept of word problem, which have been picked up from the concept of probability. Agreed? So probably now the sound is properly audible to all of us. So now it's right time to start the today's session. So total 5 number of questions we have planned to take in today's class. The first question has been experienced by Gate Instrumentation. Year of 2014, the problem was framed by IIT Kharagpur. In the same sequence, we are going to take the second question of the day. The problem has been experienced by the Gate Mechanical. Year of 2005, the problem was framed by IIT Bombay. In the same sequence, we are going to take the next question. It is not a very difficult question, but yes, require a good amount of understanding. The problem has been experienced by the Gate Civil Engineering year of 2008. The problem was framed by IIT Bangalore. In the same sequence, we are also going to take the fourth question, and this question has been experienced by Gate Electronics in recent year, last year, that means in year of 2021. It has not been written over here, but yes, this problem has been experienced by the electronics people, and as per my experience, I can say almost 80 to 90% student could not solve this problem. So again, we are going to focus over this problem also. In the same sequence, the last question of the day would be the fifth question, which has been experienced by Gate Computer Science year of 2004. The problem was designed by IIT Delhi. Anyways, keeping aside each and everything, let me focus over the first question first and read the problem carefully and tell me what would be the best most answer for this particular problem. The problem states the figure shows the schematic of a production process with machine A, B and C. An input job needs to be pre-processed either by A or B before it is fed to C, from which the final finished product comes out. The probabilities of a failure of the machines are given as, probability for the failure of a machine A is being given as 0.15, that's been 15%. Probability for the failure of the machine B is being given as 0.05, that helps to be 5%, and similarly probability of the failure of the machine C is being allocated as 0.01, that stands for 1%. And as far as the block diagram of the complete process control system is being, here the input goes. Now you have got the two parallel processor, you have got the two parallel machines to process this input, and now the output from either of A and B goes to C, and the final product comes out. Assume the independent of the failure of the machines, the probability that a given job is successfully processed up to the third decimal places is. Tell me what would be the best most answer for this given problem. It is not a difficult problem, but yes, I can say it is a problem which is very much connected to the basic concept of the probability, and as per my experience, I can say probably 50 to 60% student would not be able to crack this problem out. This has been a problem from Gate Instrumentation. So I would give around, let's take 180 seconds. Within 180 seconds, try to analyze each and individual words which has been associated with this problem. Try to understand the meaning of each and individual words, and then try to crack this problem out. 180 seconds has been given to all of you. 180 seconds has been given to all of you. Tell me what would be the best most answer for this given problem. What would be the best most answer for this given problem? I would expect each and every student who have been following my lecture, they have copy as well as pen in front of them. They should scribble all of the important data which are being supplied with along with this problem and try to crack this problem out. And if you get the answer, just post it over the live chat. So as per the Himanshu Bharti, the answer has been 0.891. Anyone else apart from 0? I gave the answer in the last video itself. You did not acknowledge. Himanshu, actually I had the fever, so I did not see your last reply. Otherwise, definitely I could have replied there itself. Himanshu, but still, when I will be explaining about the complete crux behind this problem, definitely you are going to learn so many good concepts within this problem itself. Tell me what would be the best most answer for the first question. The figure shows the schematic of the production process with machine A, B and C. An input job needs to be pre-processed either by A or B before it is fed to C, from which the final finished product comes out. The probabilities of the failure of the machines are being given. You had to find the probability that. Now the different answer have come from the myth. As per the myth, the answer would be 0.8315. As per the Pooja Reddy, the answer has been 0.89. And as per the Ankit Chaurasia, the answer has been 0.89. So uniformly 3 same answer has been found over the live chat, and that has been 0.89. Now few more answers have started coming, and they have been deviating from 0.89, and the answers have been 0.82, and as per the Mohammad Firoj, the answer had been 0.81. May I know what would be the precise most answer for this given problem? Tell me. First, the basic crux behind this problem must be known to us. Then only you would be able to crack this problem out logically. So I think your time is done. It's the right time to bring this problem towards working board, and there we would try to smash this problem out. This has been the first question of the day. Anyways, understand this problem logically first. What the problem states: the figure shows the schematic of the production process with the machine A, B and C. Obviously, if you'll go into either of the process plant, the process plant would be equipped with the different machines. How many different machines has been there or within this process plant? The 3 number of machines we had, that had been the option, machine A, machine B as well as machine C. As per the problem, it says an input job needs to be pre-processed. Obviously, before getting the final product, definitely it has to get pre-processed by the different machines. That has been sure, either by A or B. That is why they have been connected in parallel. Whether this wording has been given or not, once you read this schematic diagram, you must know one thing: the A and B, both of the machines have been connected in parallel. What does that mean of it? That means if A is healthy, B is healthy, and either A and B both are healthy, in both of the cases what is happening, your process or the pre-processing is being done between this node to this node. Could you understand what I am saying? What I expect in future, they are not going to give this wording which has been supplied along this problem. If the two systems are being connected in parallel, what does it mean of it? That means either of the system is healthy, that's it. You would be able to pre-process your product from this point to this point. That is for sure. Similarly, is fed to C. What it states, that means the pre-processing is being done till this node. Now it has to get processed through C alone. That means if there is a failure over the C, you would not be able to produce the final product. That is for sure. Could you understand what I am saying? So the crux behind this complete problem had been A and B had been in parallel, and the parallel combination of the A and B has been connected in series with the C. What it states, if A is okay, C is okay, the final product would be there. B is okay, C is okay, again you would be able to produce the finished product. If A and B both are healthy and C is also healthy, again you would be finding your final product. But if any case C is in non-healthy condition, or at any case A and B together is not in healthy condition, in that case you would not be able to produce your final product at all. you would not be able to produce your final product at all. Could you understand? Assuming the independent of the failure. Even this important word is also very important. Why? Because in future, when the events or the occurrence of a certain events are found to be independent, in that case, once we take its intersection like PA intersection B, in that case, their probability would be simply PA into of PB. That means you can say for at any moment of time, the probability of the failure of the machine A is completely independent from B, and similarly probability of the failure of machine B is completely independent from A, C, B, A, everything. But anyways, in practical it does not take place. You just understand in this way, if machine A is being failed now, in that case workload would be more in machine B and their failing probability would increase. So if you'll say the failing probability of the machine A and B is completely independent, I don't think so. See, I have worked in BRC, I know how to deal with this problem in the practical ground. So I can at least assure one thing, if A is failed, so the failing probability of the B would increase. So you can't say exactly they have been independent while failure. But whatever the data is being supplied along with this problem, definitely or happily, we had to accept it as it is. Now I would like to ask one more thing, where you would be having the parallel combination of the machine. Being an engineer in BARC, being a scientist in BARC, when I would design a system, I would try to have the parallel combinations of the machine where the failure probabilities are larger, higher, and you yourself would be able to understand. The failure probability of machine A is quite large, although the failure probability of the machine B is not that large. Is still what I will think, if the failure probability of the machine of A is being 15%, failure probability of the machine of B, let's take it's been 30%, so definitely there I would take the backup, I would take the parallel combination. Could you understand? Did you really understanding the basic crux behind this complete problem? It has been a practical problem. Once you'll go in DRDO, BRC, ISRO, definitely you are going to draw this block diagram before finalizing your complete process plant. So where the parallel combinations are required, where the failure probabilities are more. But as far as this problem is concerned, the data which they have selected for the failure probability of A and B, that does not satisfy my requirement. Could you understand what I am saying? What I am saying, when I would take the parallel combination, I would take the parallel combination when the failure probability of machines are very large, so that I would provide the backup to all of the machines. Anyways, keeping aside each and everything, few of the important crux which we can brought out from this complete analysis. Let me write over here. Yeah. The first important data which has been given along with this problem, whenever there used to be the parallel combination, no, just understand one thing. Either of the machine is healthy, that part of process would be done. Pre-processing would be done. Done. Let's take this node has been taken as A and this node cumulatively has been taken as B. That means in between the node A and B, if either of the machine is healthy, that's it. You are going to perform the well pre-production in between A to B. Yes, till this point I don't find any of the student would have any sort of doubt. So you don't expect in future this wording would be offered along with this problem. If I would frame this problem, I would expect the student would have a little bit idea. By watching the parallel combination, they should have one thing in their mind, and what is that? If either of the machine is okay, pre-processing would be done in between the terminal A and B. Next important point, if any of the machine is being in series, series combination, that machine must be healthy. There is no other choice. Must be healthy. Healthy for finished product. Finished product. Finished product. So as far as the machines which have been connected in parallel, they have been machine number A and machine B. They have been connected in parallel, and similarly C has been connected in series. C has been connected in series. Specifically in this problem, we have been looking for the probability that the finished product has come out. May I know how will you calculate that probability? That probability would be calculated, the probability that we have got the finished product. What it would be? Probability that, just try to understand what exactly I wanted to communicate through this. Probability that A and B, either A or B or both of them have been working fine. Should I repeat once again? Yes. What I am saying, you had to focus over the concept that the probability that either of the machine is been fine, either of the machine is been fine. But anyways, specifically in this problem, they have not given the healthiness probability, they have given the failure probability. They have given the failure probability. So what we are going to do over here, we are going to take the probability that the machine A is being failed and the probability of the machine B is being failed. See, in case of AND, why the multiplication is being taken place, you could have taken this as a P of A intersection B, and as the event of the A as well as B has been an independent event, obviously their multiplication could have been taken place. And once we take the subtraction with 1, may you know which condition do come? That means both has not failed together. I have seen many of the times the student used to understand this concept bizarrely, disastrously different. See what the P of A dot of P of B states. It states both have been failing together, or the probability that the machine as well as machine A as well as machine B has been failed together. What does that mean by the 1 minus of P A P B? Both of the machine has not been failed together. That includes machine A is healthy, machine B is not healthy. That includes machine B is healthy, machine A is not healthy. That includes machine A as well as machine B, both had been healthy. Both had been healthy. Could you understand what I am saying? So many of the students would think, sir, the P of A into P of B is being probability that both had been failed, and as you are taking its inversion, that means you are looking for the probability that the both are working fine. No. That means you have had the situation where A is working fine, the B has been failed, A has been failed, the B has been working fine, and at last A has been working fine as well as B has also been working fine. B has also been working fine. In the same sequence, what we are going to do over here. So this has been the process, or this has been the complete probability through which at least you would be able to pre-process the product from A to B. Now you had to pre-process the product from B to C, and now you will be getting the finished product. How it's possible? It's possible that anyhow your machine C must work fine. And how it's possible? The failure probability of the machine C is being P of C, and hence its healthiness is being defined as a 1 minus of P of C itself. And end of the day, whatever the answer you do get, that's gonna be the last most answer. That's gonna be the last most answer or the best most answer. Tell me what would be the best most answer for this given problem. For this given problem. Tell me. So let me feed all of the data which are supplied along with this problem. One of P of A is being clearly given. Just a minute. P of A is being clearly given. That's a 0.15. That's a 0.15. And similarly, P of B is being given as 0.05. End of the day, it's going to get multiplied with 1 minus of 0.01. From doing this all stuff of calculation, you would be getting the complete answer. You would be getting the complete answer. Manju, I have taken the union alone. If you want, I can show that. Manju had a doubt, sir, why did you take the union while solving this complete problem. If you want, I can show that process also. With the help of axiomatic approximation, also you can solve this problem out. Anyways, once you'll solve this problem, probably the answer which we are supposed to get is somewhere 0.89. I'm not exactly sure about it. You have the calculator in front of you. So definitely by doing the calculation, you can get its best most answer. So let me do this calculation. So here it becomes 1 minus of 0.15 gets multiplied with 0.05. Similarly, here it becomes 1 minus of 0.01. Yes. How much answer we are getting? All of the students, tell me how much answer we have been getting. So it has been 1 minus of 0.15, 0.05, and then 1.01. How much answer we have been getting? 0.9825. No means no answer has been correct answer for this given problem. No means no correct answer has been given for this given problem. How many students are live? The concurrent 9 viewers we have. I just wanted to ask from each one of you. Any means any student could not give the correct answer for this given problem. That means you have to focus a lot over the concept behind the word problems which are framed based on the concept of the probability, which has been based on the concept of the probability. Till this point, each and everything is clear. If it is clear, just write clear over the live chat. And if any sort of doubt you guys are having in your brain, no, you can put it over the live chat. I have already seen one of the doubt which has been raised by the Manju. I am going to clarify over here. But still, apart from Manju's doubt, if any doubt you are having in your brain, you can put it over the live chat. You can put it over the live chat. Aniket Sahu says, sir, please repeat once. Sir, in parallel, either A or B will work at once, right? No. Amit Kumar, I could understand what's your doubt. What Amit is saying, he is saying, sir, either the job would be processed by A, either the job would be processed by B. Dear friends, it's not the control system. It's called the process schematic diagram. What it states, the A and B had been in backup. That means the process can get processed with A, the process can get processed with B, and that depends which has been in healthy condition. And if A and B both are in healthy condition, it can get processed with either of them. So you can say the A and B machine had been a type of backup machine. So what's the advantage you will get for the backup machine? You yourself would be able to understand. At least in between the A to B terminal, pre-processing probability would increase. How? See, 1 minus of PA into PB. In future, if you bring the C block or if you bring a next block which has been in parallel with A, B as well as C, what would happen? Again, a probability would get multiplied with P of A, P of B as well as P of C, and you yourself would be able to understand this value would be going down. And as the value of PA, PB, PC, PD, PF, PF, PG, PH is keep multiplying, you can see very well end of the day this value is tending towards 0. Why? Because all of the data which are going to get multiplied would be in between 0 to 1, and as those data are in between 0 to 1, as the large number of data are keep multiplied, what would happen? This data would almost try to go towards 0 and this factor would become 1, and you can say, sir, almost it has been made sure in between A to B we are going to do the processing or the pre-processing without any failure itself. Manju, now everyone just focus over the basic concept itself. So probably Amit had the doubt. Amit, sir, in parallel either A or B will work at once, right? No. Amit, could you understand what exactly I wanted to communicate through this problem? So I don't find any of the student would have any sort of doubt now. Let me explain this complete process once again. You had a process plant. Here goes the input job. It has been a node of finished product. First, this job goes through the first processing. That processing could have been done with the A or B, and they have been connected in parallel just to increase the reliability. So in future, if the A is being failed, I can use B. B is being failed, I can use the A. Now, in future, whatever the pre-processed product do come at this node has to get processed with C alone. End of the day, the failure probability of A, B and C has been clearly supplied with along this problem, and we wanted to have what's the probability that you would be able to produce the finished product well. So what we had to do? First we had to focus between this two node A and B. We want there should not be any failure itself. What does that mean by the failure? Either A should not be failed, either B should not be failed, so put together we have been focusing that there should not be only and only one condition, that A and B has been failed together. If there is the event anything apart from A and B has been failed together, I am happy with that. I am happy with that, and that has been the equation or the mathematical expression for that particular condition. Similarly, I do not have any backup for C. That means anyhow the C has to be live, C should not be failed. If the C is failed, that's it. You are not going to get the final product. So now straight away it's going to get connected with the P of C. It's going to get connected with the P of C. Agreed? Now the Manju had one doubt. Sir, why don't we take the union? I have taken union alone, Manju. Sir, is this an independent event? Pooja, it has been clearly written. Probably you could have joined us late, but it has been clearly written. Their failure probabilities are completely independent to each other. Now the Pooja had one doubt. Sir, why didn't you take the union over here? I can take, no? I can take. So here, this complete mathematical expression could have been written as probability that machine A is being healthy, union machine B has been healthy. Yes sir, I can take that. But as A and B had been an independent event, and when we used to have an independent event, we used to deal the problem with the help of intersection. So what we are going to do over here? We can do 1 minus of P of A of H union B of H. Yes, and now I can take bar over here. That's fine, sir. That's more than adequate. Now, next what's going to happen over here? It would remain P. Now this bar would come inside, it would be A bar, and here it would become intersection of B bar. May I know what does it mean by the A bar H and B bar H? That is the failure probability of the machine A as well as the failure probability of machine B. And as we know, the event A as well as event B had been the independent event, so their intersection would lead the multiplication. So end of the day, we got to know P of AH bar, P of BH bar is very same as P of A because it has been the failure probability of the machine A, and P of B because it has been the failure probability of the machine B. So Manju, probably now you would be able to satisfy your curiosity, sir, from where this complete expression have come into the picture. Still, I know many of the students would have huge amount of doubts. So now if they have any sort of doubt, no, they can ask over here. Now even I can change this problem a bit. I could have taken another block over here. Let's take the block could have been D. And again, I could have taken the block C as well as D in parallel. May I know what would have been the condition over here? Obviously the condition would have been like this. Here you had been taken, you should have taken the probability of the failure of the machine D. Similarly, rather having the 2 number of blocks, if you have a 3 number of blocks, 4 number of blocks, continuously this multiplication would increase here itself. And if the number of parallel machines are going to go towards infinity, this factor would become 0 and this factor would become 1. And as far as this particular factor is being concerned, as the number of machines which has been in parallel with the C is being keep increasing, this factor would go towards 0 and this would lead 1, and 1 into 1 would be 1. 1 into 1 would be 1. See, such a huge mammoth technical details this problem was containing. Such a huge mammoth details this problem was containing, and I know many of the students are not actually understanding the concept behind this. And one more important thing. See, if you keep increasing the parallel combination of the machines in parallel with the A, B. See what is happening. Although you may bring this complete quantity towards 1, but is still this factor is still a factor which would be in between 0 to 1. So this factor gets multiplied with 1 is still the probability of a successful product would be much lower inside. So you had to optimize each everything. What I'm saying, you had to optimize each and everything where I should multiply this, where I should multiply this. So that is what I am saying. No, when you go into the design field, no, like in VRCs and DRDO, you also had to think what had been the failure probability of the each and individual blocks, where I should put the parallel combination and where I should not put the parallel combination. Like if I say the failure probability of the machine C is being 0.00 and 1, I would be the bekoof enough. Should I be putting a parallel combination? I don't. Why? Because if this factor do come over here, although I would not have P of D, which would be equals to 1.0009, which would lead 0.9999, such a huge value it has been. So why should I put a parallel combination in parallel with a machine whose failure probability is such a low in value? So could you understand what had been the psychic behind this complete structure? Sir, what will happen if a block is series with A or B? Anyways, great example, sir. Thanks, dear. Could you understand what I am saying? This has been a problem. Literally, I feel that has been a problem based on the concept of practical aspect. Would like to ask from each one of you, is this part clear to all of us? Is this part clear to all of us? I would like to have the input from each one of you. Is this part clear to all of us? If any sort of doubt you guys are having, any sort of preliminary doubt if you guys are having, you can put it over the live chat. Once summarize, sir. Okay. Soma Sekhar is saying, sir, why don't you summarize once? Okay, let me summarize once again. Focus over the problem. We'll go by word. The figure shows the schematic of a production process with a machine A, B and C. That means you had a process plant. Total 3 number of machines are getting involved before getting the finished product. What are they? They have been A, B and C. That's fine, sir. An input job needs to be pre-processed either by A or B before it is fed to C. Anyways, whether this sentence has been provided with the problem or not, but at least while watching this schematic diagram, you must able to know that the A and B had been put into the parallel. That means if A is working, fine, B is working, fine. If A and B both are working, still it's fine. Keep in mind, only one situation should not exist, and that is the situation where the A and B both had been failed together. If takes place, definitely the pre-processing between the node A and B would not be taken place, and you cannot even think about the finished product at all. Yes, that is also fine, sir. Is fed to C. Now the C is being an element. What I am saying, C is being an element. If it fails, that's it. You are not going to get the finished product. If it is working fine, still now it depends whether the pre-processing between the node A and B has been done or not. Once you'll see this problem thoroughly, one thing is being clearly said. See, probability of the failure of the machines are being given. They have been the failure probability. If the student would say, sir, this has been the success probability, you would be the last person in the bekoof list. Why? Who would have such a low healthiness of your system? See what it says, only 50% time this machine would be live, only how much, 95%, sorry, only 5% time this machine would be healthy. No, yeah, nobody is going to purchase this sort of machine. So even with the help of data itself, you could have figured it out. This is not the probability of the healthiness of the system. It has been the probability of the failure of the system. If somebody would say, sir, I have designed a system, I would say, okay, Pooja. Now Pooja would say, sir, the healthiness probability of my system is somewhere 5%. So I would say, Pooja, you redesign that system once again, because I cannot tolerate with such a low healthiness of the system. So now the people are saying, sir, I had a little bit doubt whether the failure probability was given or the healthiness probability is being given. see how those data can be selected and how those data or how those machines would survive in the practical scenario. No, obviously they have been the failure probabilities alone. They have been the failure probabilities alone. Yes. In the same sequence, assuming the independence of the failure, the Pooja Reddy had the doubt, sir, where it has been clearly mentioned that the probability of the failures of the three machines A, B, C had been independent in nature. It has been categorically marked over here. So Pooja, so that part you had the doubt, no? Now it has been clearly mentioned over here. The probability that a job is successfully processed up to the third decimal place. Such a huge problem it has been. So focus over node by node. So pre-processing has to be done in between the node A and B, and then the pre-processing has to be done in between node B to output. Focus over the A and B. How the complete pre-processing is possible? You can include either of the condition. A is working, B is not working. B is working, A is not working. A and B both have been working. Put together, it has been the condition. It has been the condition. Probability that the machine A has been in healthy condition, union machine B has been in what? Healthy condition. What does that mean by the union? Union, that means A or B, B or A, or intersection of both. That means if A is working, B is found failed, B is working, A is been found failed, or A and B both have been working. See, as A as well as B has been the independent event, and whenever we deal with the independent event, my basic intention would be to bring that complete axiomatic form to the intersection. Deliberately, I applied the bar over the top and one has been taken out, and that bar had come inside, and once the bar had come inside, you yourself would be able to understand P of AH bar. What the AH indicates? It's been the event when the machine A is being healthy, and what its bar indicates? It indicates the machine is being failed. Machine is being failed. Same thing has been happening, and end of the day you are going to get the answer. You are going to get the answer. And one of the best thing regarding this complete concept, did you notice or not? This value would never exceed 1. Why? Because this factor would always be in between 0 to 1. This factor would always be in between 0 to 1. If you have, let's take 10 number of series systems or series machines, then also those all factors are going to get multiplied, whose value would be in between 0 to 1. So end of the day, after multiplying those all factor, result would always be 0 to 1. And as per the standard problem based on the concept of probability, the answer should not exceed 1. Answer should not exceed 1. Because I know many of the students, they might be calculating the problem in such a way. मैं ये जानना चाहूँगा कितने लोग ये समझ रहे हो? What I am saying, many of the students might be solving the problem in such a way. If I'll have the 5 to 6 number of parallel combinations of the system over here, no, I will have, let's take 4 to 5 number of parallel combination of the system, their probability will go beyond 1. May I know how many students who have been solving the problem in such a way, if the number of systems are keep increasing, their probability would go beyond 1. I can understand all of the students, the way they have been calculating the answer for this given problem, no, if I'll keep increasing the parallel combination of the systems, no, end of the day they would be getting the answer more than 1. So would like to ask from each one of you, the way you guys have solved this problem, if I'll increase this system in parallel with this 9 number of system and 10 number of system, whether you are getting the answer greater than 1, yes or no? Your answer must be yes or no. Aniket Sahu is saying, sir, I have done this problem first. But what was your answer, Aniket? Everyone had the probability of the final product to be come out somewhere 89%. And as per the Amit Kumar, the final product probability was 0.18. Amit, such a low probability we cannot tolerate in this competent environment. Pooja Reddy is saying, yes, sir. Yes, sir. I thought like that. Yes, that's what I am saying, no, Pooja. The answer can't be greater than 1, and probably the student who might be doing the calculation in a different way, they may lead the answer greater than 1 also. I know what are the different process through which you would approach this problem and probably would get the answer greater than 1. Yes, Aniket, that's what I am saying. That's what I'm saying. But one thing has been quite sure, if you follow my process, if you follow my fundamental, your answer would try to tend towards 1, but it would never cross 1. It would never cross 1. So may I know, how was the level of this problem? How was the level of this problem? And I forgot the name of the person who was saying, sir, you did not reply the comment which he has posted in last day. May I know what was his name? Probably Himanshu. Himanshu. Tell me, Himanshu, which concept you did use while solving this problem? It is a utterly well designed problem. See how much time we have spent over the single problem itself. 45 minutes, and sometime it's required. Sometime it's required. That's what I say. If the people would say, for the each and individual problem, you need not to spend more than 3 to 5 minutes. I don't agree on that particular argument, because this sort of problems are really who are the eye-opening problems, and now you would be able to address logical problem even into the more productive way. Okay, then in the same sequence, now it's right time to take the next question. This has been the next question, and probably much comfortable problem in compare with the first question. The problem has been experienced by the gate mechanical. Year of 2005, the problem was framed by IIT Bombay. Read this problem carefully and try to get the best most answer for this given problem. The problem states, a single dice is thrown twice. That means if nothing is being given, we will presume that the die which has been rolled twice, it had been a fair die, which would have the 6 different faces, and the probability for the occurrence of the each and individual face is being equiprobable 1/6. What is the probability that the sum is neither 8 nor 9? The 4 different options were attached along with this problem, which starts from 1/9 goes to 5/36. C option has been 1/4, and the last option has been 3/4. 3/4. Yes, Pranali, it has been a problem. I can see in many of the books, the way they have given the solution, no, they themselves do not exactly know how they have given the solution. I know about it. That's what I have brought this problem once back. Although this was the last problem in my last video, still I brought this problem because I was knowing many of these students, or I can say most of the students, would not be able to crack this problem out. Tell me, what would be the answer for the option or the question 2? What would be the best most answer for the question 2? Many of the times it has been communicated to all of us. If the calculation is difficult from one side, so why don't we start from the other side? And if we start from the other side, obviously with the help of the concept of complement, we can address that problem there itself. A single die is thrown twice. That means how many total possible events you can have over the sample space? 36. 1 can get connected with the 1, 2, 3, 4, 5, 6. 2 can get connected with the 6 different options, 1, 2, 3, 4, 5, 6. So one thing it is quite sure, if the 2 dice is been rolled, or the 1 die is been rolled twice. Let's take this has been the first die, which has been rolled once, and now it has been rolled twice. How many different possibilities you'll have? The 36 different possibilities you'll have. That is for sure. And as far as this problem is being concerned, your favorable events being, what is the probability that the sum is neither 8 or nor 9? That means apart from 8 or 9, whatever the sum do come into the picture, those all outcomes are going to be my favorable conditions. May I know what are the different sums would be my favorable condition? You can see by yourself. The minimal sum could be 2, because the minimal digit which can get offered in the first trial is 1, and similarly minimal digit which can get offered by the second trial is only 1. So it could be 2, can go to 3, can go to 4, 5, 6, 7, 8, 9, 10, 11, and the maximum number which can be experienced by either of the dice is being 6 and 6, and hence it would be 12. So as far as this particular problem is concerned, your favorable conditions has been anything apart from 8 and 9. So forget about 8 and 9. So you had to focus over the event at which the addition would be 2, 3, 4, 5, 6, 7, 10, 11 and 12. As I said, I will forget about 8 and 9. I would just focus over the 8 and 9 itself. Whatever the probability do come, I would just subtract with 1. We are done. We are done. We are done. Agreed what I am saying? So what we are going to do over here, we are just focusing over the different events in sample space whose sum is going to lead 8. So may I know what are the possibilities you will be having? 1? No. The first digit cannot be 1 because it requires 7, where in this phase you can't get 7. So it would be 2, 6. It could be 3, 5. It could be 4, 4. It could be 5, 3. It could be 6, 2. That's fine, sir. Similarly, if we'll go behind 9, so the least data through which I can start with is going to be 3, then 6. Similarly, 3, then 4, then 5, then 6. How many total favorable number of conditions we had? 1, 2, 3, 4, 5, 6, 7, 8, 9. Out of 36. Out of 36. Yes. So the result had been 1 upon 4. But it has been the probability that the sum would be either 8 or 9. If we had to rule out it, 1 has to come towards outside. Yes. And hence I can say 3 by 4 has been the probability that the sum will neither be 8 nor be 9. Yes, the best most answer is going to be option D. Best most option would be option D. Anyways, we would bind up our video here itself because as I have communicated earlier, I had a little bit problem with my health. So just I came to teach you guys such that you would not have long gap. Because what happens once you'll have the long gap, now you will go in your own world and you will not be following the lectures which has been delivered in such a huge sequential manner. End of the day, you are going to go into the big loss. Anyways, this has been the agenda behind today's video. We would come out with few more number of word problems. Probably next 2 to 3 days we are going to take the different kinds of the word problem alone. And you can say one of the mammoth most problem which has been experienced by the electronics people, yes, this year. 4th question, utterly well designed problem. Probably we would see in tomorrow's class. Till then, bye bye, take care, good night.